Okay, let's go ahead and solve for beta, which is the feedback factor of this inverting Schmitt trigger circuit, where beta is equated to Vp, or the voltage at my positive terminal, over Vout, or the voltage output, where we know that for an ideal op amp, we can say that the current going into my positive terminal, call this Ip, is very close to 0 amps, and the current going into my negative terminal, call this In, is also very close to 0 amps. As a result, the current going through this resistor R1, called this IR1, is equated to the current going through this resistor R2, called this IR2. So I can say then that IR1 is equated to IR2. And if we go ahead and write some equations for IR1, we say that this is 0 minus Vp over R1 is equated to Vp minus Vout over R2. So then I can pull out a Vp, and I'm left with 1 over R1 plus 1 over R2 is equated to Vout over R2. Therefore, this becomes Vp times R1 plus R2 over R1 times R2 is equated to Vout over R2. And lastly, then Vp is equated to R1 over R1 plus R2 times Vout. As you can see, if I divide Vout to this side, this here is my feedback factor, or my beta. And the reason why we care about a circuit like this is because it has memory and is a closed loop system. So to prove that, we say that when this circuit is turned on, my original Vout is equated to my AV gain times Vp minus Vn. And the equation, or the solution to this Vout, is equated to plus V saturation or minus V saturation. And this first output, or call this V sat, is plugged into here. And then we find a new Vp using this equation. So we find a new Vp, and then we plug it into my next Vout equation. So as you can see, this system is a closed loop system because it's closed loop in this sense, and it has memory because the current input Vp is dependent on a previous output Vout. Thank you.